Woohoo! Welcome back. Today we're going to continue to talk about equations of lines, and specifically, what does the equation of a line look like? And what I'll say is, in general, when you're looking at the equation of a line, you generally, if you're using x and y, you'll see an x and or a y. You don't always have to have both, but you frequently will have both. And there will be no fancy stuff. So no x squared, no y squared, no radical x, no radical y. So just plain x and y. Things that are related to lines are called linear. So these are going to be linear equations. So we're going to start with the standard form, ax plus by equals c. And you'll see that right away, my example is completely different, dum dum dum, because I've got 3x minus 4y, and I said it was ax plus by. And of course, I'll point out that b could be negative 4. So each of these capital letters, A, B, and C, could represent positive or negative numbers. These could be whole numbers, they could be integers, they could be real numbers. So we've got a lot of options here. But what's interesting is if you start with 3x minus 4y equals 12, you can easily see that we've got an x and a y. No fancy stuff, no x squared or y squared or radical x or radical y. So that's all good. But the problem is that even though this is in what we call standard form, it's not the most useful form, and it's not the form that a lot of people use to graph or to find out more information. So what we generally will do is when we get a line in standard form, we're going to go ahead and solve for y. So let's solve for y. My y is right over here. I'm going to go ahead and subtract 3x from both sides. I get negative 4y equals negative 3x plus 12. And then even though I'm not thrilled about it, because I already can see, I'm going to have some complications here, I'm going to go ahead and divide everybody by negative 4. So divide both sides by negative 4. And of course, that comes down to just dividing each term by negative 4. So I'm going to get y equals, and then I notice a negative over a negative. So two minuses make a positive, even when they're multiplied or when they're divided. Either way. So I'm going to end up with positive 3/4 x. You could also write it as 3x over 4 if you prefer. And then this little sneaky guy, because there's a single minus, this is going to be a negative 12 divided by 4, or 12 divided by negative 4 is negative 3. And so this is that same line written in this form. We've solved for y. So this is a different way to write lines. Woohoo, yay! Okay, so then, dum dum dum, you'll notice, almost as if I anticipated it, I've got the same equation right here. So we're going to continue with this equation, but we're going to talk about what this is called. And this form, when you solve for y, you get a form that some people just call the y equals mx plus b form, because it's so famous. It's also called the slope-intercept form, because the really awesome thing is if you solve for y, whatever number is in front of x will be your slope, which is really cool. The coefficient of x is the slope. And then whatever number is sitting over here is the constant. That's going to be the y-intercept. That's what happens when x equals 0. So this is a really great form because it gives you both the slope and the y-intercept. So that's why a lot of people will just automatically solve for y to get to this form. So this is the equation we ended up with on the last page. And so the question is, what are the slope and y-intercept? And the answer is, it's really straightforward. The slope, which is m, is 3/4, and the y-intercept is -3. Now you could also write that as an ordered pair. That would be the ordered pair 0, -3. So the y-intercept being -3 is the point where it hits the y-axis and x equals 0. On the other hand, the other way you could use this form is if you happen to know you want the point 0, 4, so that is a y-intercept. How do I know it's the y-intercept? I know it's the y-intercept anytime x equals 0. So if x equals 0, that's the y-intercept. That's the point where the line itself runs into the y-axis. And if the slope is -5, well, then all I have to do is take my formula, y equals mx plus b, and instead of the m, I'm going to put in the slope, -5x, and instead of b, I'm going to put the y-intercept. And that's it. That's the whole thing. So this formula is really useful because without a lot of work, I can construct the equation of a line if I know the slope and the y-intercept. Woohoo, yay! Okay, next up. Dun, dun, dun. The next question then becomes, wait a minute, what if I don't know the slope and the y-intercept? What if I know other things? And the answer is, well, then we do have one more form. It's called the point slope form. And this one on the surface looks very complicated. People look at this and they go, oh no, what is going on? There's y's, there's y1, there's m, x, x1, it's all. And so what I want to do is I want to step back a little bit and say, okay, let's look at the formula for the slope. So remember that the formula for the slope is y2 minus y1 all over x2 minus x1. And what I would like to do is I would like to rewrite that. I would like to write it as m equals y minus y1 and x minus x1. So all I've done is taken the y2 and the x2 and rewritten them as y and x. So just a little facelift, but I'm not changing the actual structure of the formula. And then what I want to do is I want to take this formula m equals y minus y1 all over x minus x1, and I want to multiply both sides by x minus x1. And then I get m x minus x1. I'm allowed to do that. I'm allowed to switch the order around because of the not transitive property. Hello, the commutative property of multiplication. There we go. And then over here on this side, I end up with, and here I don't want to cross out too hard so you can't see what's going on. I can cross these out, those cancel, and I get y minus y1, and you'll see if I change the order, y minus y1 equals m times the quantity x minus x1. That's this formula. So this formula comes directly from the definition of slope. So this is just playing with the slope formula, gives you point slope form. So, but what does it mean? And this is going to be the formula that's going to help you the most. Although, to be honest, some folks do use this formula just as much. So these two very important formulas. But what I'm going to do is I'm going to show you how to use this formula to find the equation of the line passing through those 2 points. So I've got the points 3, 4 and 1, 8. And whenever I've got 2 points, I can go ahead and I can find the slope. So the slope here, y2 minus y1 all over x2 minus x1. Okay, so I pick one of the y's. I'm going to start with 8. So I've got 8 minus 4. Since I started with 8, I have to then start with 1 in the denominator, right? These two go together right there. And I'm going to subtract 3. So I get 4 on top and -2 on the bottom. So that gives me -2. So my slope is -2. And then I just pick one of the 2 points. It does not matter which one you choose. You choose the one that seems friendlier to you. I'll go ahead and just start with the 3, 4. You can use either. And then I'm going to use my formula, and I'll rewrite it here so you can see it. Y minus y1 equals m times the quantity x minus x1. So the way to use this formula is to recognize that whenever we have a y with no subscript, we're usually thinking that that's going to be a variable. And then whenever we have a letter like y with a subscript like 1, y1, this should be a number. This should be a constant. Not always, but a lot of times. So what I'm going to do is I'm going to rewrite this as y, it stays y, but then this y1 is going to be my y value from the point, which in this case is -4. Then I've got my slope, -2, and then again I use x minus, and I'm going to use the x value, 3. And that's the equation of this line. Now, if I want to simplify, like a lot of times I do want to solve for y, I multiply out. So I multiply -2 through, and I get -2x plus 6. And then I'll add 4 to both sides. And I get y equals -2x plus 10. Now, I said earlier, it doesn't matter which point you choose. So I want to show you, this is a big or. You don't have to do both of these. You would just pick one. If I take my slope equals -2, and instead of 3, 4, I use 1, 8. Let's try that one, the other point. So again, I'm going to use this formula. So I get y and then minus y1, so y minus 8 equals, the slope is -2, x minus, and then I use the 1 right there. So I plug in all these values into the formula. Now you'll notice these at first do not look at all alike. They look really different. But once we solve for y, we'll be able to see we got the same equation, that same line. So y minus 8 equals, let me multiply through, -2x plus 2, and then I'll add 8 to both sides. Y equals -2x plus 10. And you can see we get the same equation. So it's the same line. Oh, you can't see that I'm writing that. Sorry about that. I sometimes get excited and I just keep going and I forget to look up. There we go. I know, you totally understand when you just get carried away with math and you're just like, oh my gosh, this is so great. I'm just going to keep doing math forever. So we can use this equation, which is called the point slope equation, with either one of the points we're given, either 3, 4 or 1, 8, and we can find the equation of the line. And remember, this is called the slope-intercept form. And this right here is called the point slope form. And mostly they're helpful if you know the names of them. So if someone asks you, they say, well, write it in slope-intercept form, that means solve for y. And if they say use point slope form, you'll know they mean this one. So it's a good idea to know these, to have these memorized. Okay, so we're going to go ahead and do one more. Woohoo. One more problem. Yay! And then if there's time, let's go ahead and graph it. Woohoo! So write an equation of the line passing through the points, and I've got the points 3, 4, and I've got the points 3, -2. And we want to write it in point slope form. So point slope form is this one. So it looks like that. Okay, so what are the steps? So the steps are that we're going to go ahead and find the slope. That is usually the first thing. If we're given 2 points, we can figure out what the slope is. So remember, to find the slope, I take the difference in the y's, the rise, y2 minus y1, all over x2 minus x1. So we pick one of these. I'm going to start with 4 and subtract -2. Now, if I start with 4 on top, that means I have to start with 3 in the bottom. And then I go, oh no, dun dun dun. What happened? Up on top, I've got 4 plus 2, which is 6, right? But what's happening in the denominator? Oh no. So what happens when we get 0 in the denominator? The answer is nothing. We stop. We can't do any more. So then the question is, what are we going to do? So I'm going to say, instead of panicking, we could panic. If you want to panic, pause the video, panic, and then hydrate, and then come back. But let's go ahead, and I'm going to say, you know what? Let's not look at that, because we don't know what happened. But let's approach this in a different way. Sometimes you can graph an equation or graph a couple points and figure out what's going on there if your work gives you something that we're not really sure what to do with. So, okay, I'm going to give myself, dun dun dun, I do not see my, there it is. And I grab my handy dandy ruler, and I'm going to draw myself some axes. Okay, there's my y-axis. There's my x-axis. I need some scale. I'm going to go ahead and use 1 for 1. What does that mean? This is going to be 1, this is going to be 2, this is going to be 3, 4, etc. Remember, for my graphs, what I ask you to do is I ask you to include at least one number, one scale in signifier on each axis. Now, I've gone above and beyond. I've written in all the numbers. You don't have to write them all in. That's a matter of personal taste. So I've got the points 3, 4. So here's the point 3, 4. And then I've got the point 3, -2. Here's the point 3, -2. So here's 3, 4. Here's 3, -2. And let me connect the dots. Now, here is a professional hint from a professional graph drawer, because I kind of draw graphs for a living. When you're graphing a line, do not go careening through numbers. You can do a little gap so it looks cool. And that way you can still read what you've written, and that's fine. Some people would say, no, don't do that. But if you're just trying to draw a line and everyone knows it's a line and you're being clear that it's not broken there, you can just give yourself a little gap. Now, if you're worried, if you're like, nope, nobody will know it's actually a line, you can go ahead and just draw right through, but then it makes it harder. It looks a little smeary. So it's up to you. Okay, so let's take a look at this. What have we got? It turns out this is a vertical line. The interesting thing about a vertical line is that there is the slope is undefined. The slope is the rise over the run, but since it's perfectly vertical, the run between any 2 points is always going to be 0. So the denominator is always going to be 0 in slope. So slope is undefined. So we just know that. So if you start to set up the slope and it is undefined, you're pretty certain you've got a vertical line. Now, the problem is we still need to figure out what the formula is. And a vertical line has a really interesting formula. A vertical line has a formula that follows whatever x is, because x is the one that's unchanged. Y can be anything, but in this case, in both points, x equals 3. So that's our equation. So that begs the question, what does it look like if you have a horizontal line? And I am, because my ruler is being a little smeary right now, I'm just going to go ahead and freehand this. I know. Très dangereux. Okay, so we've got x and y. And I'm going to pick out, let's see, I'm going to pick this horizontal line. Wah! Okay, kids, that's why you always use a ruler at home, because it gets all wiggly woggly. Sorry about that. So if we have a horizontal line, now I don't have any scale, so there's no way to know for sure, but if I tell you this is 1, then you know this is 2, and this is 3, and this is 4, and so on. And this is 1, and this is 2, and this is 3, and so on. So what do you guess the horizontal line would be? It goes through this point at 0, 2, and it seems to also go through a point there at 3, 2. So what would the horizontal line, the formula be? You got it. Horizontal lines have the formula according to what the y is. The y is unchanged. X could be anything, but the y is the one that does not change. So, woohoo. What have we got? We've got a horizontal line. The equation is y equals 2. And the last thing is, what's our slope? Well, if I pick off those 2 points, we can confirm it. You might guess, does it go up? No. Does it go down? No. So what would your guess be for the slope? I'm going to go ahead and I'm going to start with this one. So we've got 2 minus 2 up top. That kind of gives it away, doesn't it? And 3 minus 0 in the bottom. So I get 0 over 3, which equals 0. So the slope on a horizontal line is 0, because it doesn't go up and it doesn't go down. It's just flat. It's like the bunny hill. And a vertical line, the slope is undefined. Vertical line, the equations are x equals 3. Horizontal line, the equations are y equals 2. You guys are awesome. Woohoo! Yay! Sorry about all the smeariness and, all the sunshine. I know Godzilla and I are creatures of darkness, so we're going to go crawl under a rock and pick up everything the cats have just knocked over. And I hope you can take a break, go get a snack and, hydrate a little bit, maybe go outside, look at something green, and I will see you right back here. And we're going to talk more about slopes. Woohoo! Woohoo! Yay! Math on!